Welcome, this is Mr. Sutton with the IM373 Part 2 homework solutions on right triangle trigonometry. To find the missing angle on this triangle, since we have two sides, we're going to go ahead and use SOHCAHTOA. Now the sides that we have here, we've got the hypotenuse and we have the side across from the angle, the opposite side here. So we are going to use O and H. So that's the sine function. Sine equals opposite over hypotenuse. So we've got the sine of x, the angle we're looking for. The opposite side again, that's going to be this 14 across from the angle, and that's going to be divided by the hypotenuse of 16. So to find the angle, we just have to do inverse sine of 14 over 16, and let's see what that comes out to on the calculator. So doing second sine on the calculator, again we have 14 divided by 16, and that's going to be 61.0. On this problem, we have two sides of a right triangle, and we want this missing angle between them. So this means we're going to have to use SOHCAHTOA. Now let's take a look at the sides that we have. We have the hypotenuse for sure, and then we have the other leg of the angle that's not the hypotenuse. So this is the adjacent side right here. So that means if we have adjacent and hypotenuse, we have ka in SOHCAHTOA. So that's cosine equals adjacent over hypotenuse for the ratio. So we've got cosine of the angle we're looking for, which was x, equals the adjacent side, that's 7, over my hypotenuse of 12. And in order to actually solve for x, I have to take cosine inverse or arc cosine of both sides. So I can write x equals cosine inverse of 7 over 12. And now I have to plug that in the calculator. So I'm going to do second and then cosine, and then we've got 7 divided by 12, and just press enter. You can close the parentheses or not. And in degrees mode, this is coming out to 54.3. For this problem, I want the angle here in my right triangle. Since I've got two sides already, I can use SOHCAHTOA to figure this out. Now the sides that they gave me, the side across from the angle here, this 10, this is our opposite side. And the side that's one of the legs of the angle, but it's not the hypotenuse, this touching side here, that's 22, that's the adjacent side. Opposite, adjacent, that's TOA from SOHCAHTOA. So we use tangent equals opposite over adjacent. So then we can write tan of x, the angle we want, equals the opposite side of 10 over that adjacent side we were talking about of 22. And to get the actual value of x, I'm going to need to take inverse tan of both sides. So I end up with x equals tan inverse of 10 over 22, which I now go to the calculator for. On the calculator, we're going to do second and then tangent, and then we've got 10 divided by 22, and that's going to come out to 24.4. Now this is an angle, so that's degrees. On this problem, I want this missing angle given two sides of a triangle, so we're going to use SOHCAHTOA to find that. So we've got the side that's across from or opposite from our angle, and we also have this leg of the angle that's not the hypotenuse, so the adjacent side. If we have opposite and adjacent, that's the TOA part of SOHCAHTOA, so that's tangent equals opposite over adjacent. So tan of my angle, which I'm going to just call x, equals opposite, that's this 6 side here, over the adjacent side, 8. And now to actually solve for my missing angle, I have to take the inverse tangent of 6 over 8, and I need the calculator for that. So we've got second tangent, and then we're going to do 6 divided by 8, enter, gives me 36.9, and that's in degrees if I round that off. On this problem, we're trying to find this missing side of the triangle. Since we only have one side and an angle and it's not a special triangle, we're going to go ahead and use SOHCAHTOA. Now taking a look at what we've got here, based on this angle, we're looking for the opposite side and we have the hypotenuse. So opposite over hypotenuse, that's the SO part of SOHCAHTOA. So that's sine equals opposite over hypotenuse for the ratio. So we have sine of our angle, 39 degrees, equals the opposite side, that's x, that's across from the angle, over the hypotenuse, that's that 19. And now solving for x, that's going to be 19 times sine of 39 degrees, which we will enter in the calculator. So here we go. We've got 19, and then we're going to do sine of 39, and make sure we're in degrees mode. Press enter. That's about 11.9. We want the nearest tenth, so this actually rounds off to 12.0 if I round it to the nearest tenth. On this problem, we are looking for a missing side, and we have one other side and an angle that's not a special angle like 30, 45, or 60. So in this situation, we need to use SOHCAHTOA. Since I'm looking for the adjacent side here, the side that's part of the angle, but it's not the hypotenuse, and since I'm given the opposite side across from the angle, opposite and adjacent means we have to use the TOA part of SOHCAHTOA. So that's tan equals opposite over adjacent. So tan of 41 equals opposite side of 12, that's the side across from the angle, divided by our adjacent side of x. To get x, I have to multiply by x and then right away divide by tan of 41. So basically switch these two things to get 12 over tan of 41. And at this point, it's calculator or nothing. On the calculator, we've got 12 divided by tan. Here's tan, 41. And that's coming out to, let me make a parentheses instead of a 0 up there. That comes out to 13.8, nearest tenth. To find the missing angle on this problem, since we've got a right triangle with two sides given, we're going to try SOHCAHTOA. We have the hypotenuse and the non-hypotenuse leg of the angle, which is the adjacent side. Adjacent hypotenuse means we're using ka from SOHCAHTOA. So that's cosine equals adjacent over hypotenuse. So we can say cosine of x equals the adjacent side. We said that was 14. That was the non-hypotenuse leg. And then we're dividing by our hypotenuse here of 6 that we can find because it's across from the right angle. Now I do inverse cosine of both sides. So I've got x equals cosine inverse of 14 over 16. And let's use the calculator to get this. So on the calculator, we do second cosine. And then we've got 14 divided by 16. So cosine inverse of this is going to come out to 28.95 and some change. So if I round to the nearest tenth, that has to be a 29.0. And that's in degrees. For this one, I'm trying to find an angle in a right triangle, and I've already got two sides. So they gave us the hypotenuse and also the side across from the angle, which is the opposite side. Opposite and hypotenuse, that's going to be the SO part of SOHCAHTOA. So we write sine equals opposite over hypotenuse. So then sine of x, that's the angle we want, equals the opposite side. We said that was the across side here of 6. Hypotenuse we said was 10. But to actually get x, I need to take sine inverse of both sides. That'll get rid of the sine and allow us to write x equals sine inverse of 6 over 10. And for that, I need the calculator. So let me do second sine. That gives me sine inverse. 6 divided by 10. And press enter to get about 36.9, and that's in degrees because that's an angle.